Yeah, so the first law simply says that things retain their state of motion. So things retain their state of motion. If I were to explain this in mathematical terms, I'll say if acceleration is zero, velocity is constant. Okay. So that means if there is no acceleration, velocity will not change. So if velocity is zero, it will remain zero. So if something is stationary, it will remain stationary. So if its velocity is zero and you're not accelerating it, it will remain at rest and it will not move. It will remain stationary, it will not move. And if things are moving and that thing is moving with constant velocity, that's very important. If it's moving at constant velocity, then it will not change that. So it will not change its direction and it will not change its magnitude. So velocity is a vector. So if velocity is going to be a constant, in the case acceleration is zero. Okay. So usually it's phrased like that: things at that are stationary will remain stationary and things that are moving constant velocity will remain moving like that unless acted upon by an external force. And that is same as saying if acceleration is zero, velocity will be constant. Where have we seen this? We have seen this when we talked about velocity is distance over time or displacement over time. What were we actually saying? We were saying that the displacement that it covers and the time it takes, they are both directly related by the velocity that they have. So obviously that direct relation comes from the fact that there is no acceleration. The second law that we have is probably the most famous law here. Uh, Sorry, that's the third law. So this law basically defines force. So the law says that F equals ma. Again, that's not what Newton said, but we have paraphrased it. So this is the defining factor of what force is. So it's saying that when you apply a force on things, they move and they move in proportion to what mass they have. Or in other words, the acceleration that is produced on something is directly related, is affected by the mass, which is going to be constant. So if I were to think about it in another way, I will say that F is directly related to A, where M is constant. And this law, obviously, it does not hold if mass starts to change. And in relativistic aspects, or when things uh, move at speeds that are closer to the speed of light, these things will obviously change and mass will not be constant, which means that mass will also change. So the law does not hold. So this law only is applicable where mass is not changing, mass is constant. And that is the case in usually, like, yeah, all the real life experiences that you get will have mass not changing. Where will you actually see this law breaking down? For example, when you use GPS, then those satellites and the way they communicate to the earth is governed by laws that don't really follow F equals to ma. Anything that has light involved in it, that will be affected by this. So far we know that if you apply force on something, it will make things move. That's the first thing. And how does it make them move? Obviously it accelerates them, it changes the speed at which they're moving. We know acceleration is change in speed with change in time. So it starts to accelerate stuff, and that acceleration is directly related to the force that you apply. So if you apply more force, acceleration will be high. If you apply less force, the acceleration will be low. And what is not changing in all of this? Mass is not changing. So mass is the constant of proportionality. So where have we seen this law being applied? Whenever we talked about equations like v equals u plus at, that's an equation where we see that acceleration is applying, so the distance isn't really that straightforward. There's another equation that you don't need in O levels, which relates to this, that is s equals to ut plus 1 by 2 at squared, or v squared minus u squared is equal to 2as. These things you don't really need to know for O levels or IGCSE, but they are what govern things that are accelerating and how their distance, how their velocity, how their initial velocity, all of that depends on the force that you apply on them. Where have you seen it in O levels is air resistance. Whenever we talk about the idea of air resistance, we talk about a force that is canceling out the weight that you have. And obviously that weight will be affected by the acceleration or the net force that you have. Similarly, when things fall, they're falling because of their weight, and that weight is a force. So they keep on accelerating. The speed keeps on increasing. It's not that they're moving with constant velocity, and that is because the earth is pulling on them and they fall with a rapid acceleration. The third law, also a very famous law, it simply says that in mathematical terms, it says that the sum of forces is zero, which may sound really, really weird. How have we usually heard about it? We usually think about it like every action has equal and opposite reaction. Okay. So people extend this to things beyond the scope of physics, like beta padhoge to pass ho joge, nahi padhoge to nahi pass hoge, और बारिश आती है तो पानी आता है और बारिश नहीं आती तो पानी नहीं आता. So people try to extend this law to generalizing this to life and all that, but it doesn't really have to. In terms of physics, we just say that forces, whenever you apply them, they're always going to occur in pairs, and that's a very, very important perspective that you need to have. And it took him a great deal of thought to figure this out. Forces always occur in pairs, and those pairs obviously they cancel each other out. So the forces are the overall forces that are applying in a certain scenario, they are zero. So a simple example of this is that, let's suppose when you walk, what do? So you push the earth back through your feet, and the earth propels you forward in response to that. So when we are moving, we're pushing the earth back. Or when we see Michael Jackson move, he's pushing the earth forward. So earth pushes him back. Similarly, when you swim, you are going to push. So for example, if you talk about uh, when you're moving with no particular special stroke nahi kar rahe aap, then you are just pushing the water back and the water pushes you forward. So for example, in breaststroke, you just push the water back with your arms and water pushes you forward in response. And the more you push, the more force you apply, the faster you move forward. If you're talking about backstroke, then you push the water again in a different direction and you move in the opposite direction of that. We see it happening so many times that we actually start to think that it's a natural thing. For example, if you're playing tennis, then you will bring your arm and you'll hit the ball. But then that ball, as it goes away from you, it's the racket is going to be pushed back with the same force, which is a recoil. And all the players who have played tennis or all that know that whenever you start, that recoil is hard to manage. Similarly, in all the sports, in all the physical activities, we see this. Cars move like this. So, for example, if a car has, so this is a car, okay. So, if this car is moving in this direction, then in what direction are its tires pushing the earth? The tires are going to push the earth back. And that is why, so if you zoom in, you will notice that the tires actually push the earth back, and that is how the car moves forward. So there was this MCQ in the exam based on this. There's the car is moving in a certain direction. How is the tire turning? So that is anti-clockwise right now. So every action has equal and opposite reaction simply means that the forward force that you apply on one body is the same as the backward force that's applied on the other body. So that's an important idea here, that both of these forces are on different objects. So that's an important insight from this. Because if you apply the same force in the opposite direction on one object, the things will not move. It is only when forces are on different objects. So for example, when you're swimming, you're pushing the water and water is pushing you. So the force of water is upon you and the force of that you apply is upon the water. So not the same object. In this case, earth is being pushed back and the car is being pushed forward. So different objects being subject to these forces that are equal but opposite. When I say equal, what I mean is that the size of these forces is the same And when I say opposite, I mean that the direction is exact opposite. So if one is at an angle of 30 degree, the other would be an angle of 180 degrees different from that. So that will be 210 degrees. So that's also important. The angle is exactly opposite, which means 180 degrees flipped. All right. So these are the three laws that govern how things move. And one of these laws governs, defines what force is. Force is equal to MA, and MA simply means that M is constant, it does not change. So if it starts to change, then this law doesn't apply anymore. So in simple words, it's meaning that the force that you apply will be creating an acceleration, and that acceleration will be directly proportional to it. So the more force you apply, the greater the acceleration that you can produce, and the less force you apply, the lower the acceleration you can produce. And the mass is the defining factor in there, the limiting factor in there, which is going to be this constant thing. All right. So how do you add forces? They're vectors. You add them just like you would add any other vector. For example, if you have an object and this object is being pushed upon by different forces, this is F1, F2, F3. So how will it move? It will move based on its net force. So the idea of net force is that it is the sum of all individual forces, and it is not just the regular sum, it's a vector sum. So vector sum is you take each vector as it is and you just copy them. So we have seen this before, that you copy this vector here, you copy this other vector here and put it right where the other one ends, and then you take this vector and you put it where the other one ends. Okay, so for example, I could put it here. So my starting and ending point is going to determine what my net vector is going to be. So right now, my net vector is starting here, ending here. So this is my net vector. This, let me change its color. So this thing in red is what my net vector is, the overall vector. So this thing, this object, when it's subject to these forces, it will start to move in this direction, and that is the magnitude of force that it will experience. Obviously, if there is an opposing force, that force, the net force will be reduced, and that means that the amount will be lesser. So when things move because of forces being applied, we call that dynamics. When things move without the effect of forces, when they're moving in constant speed and all that, or your exam usually talks though about saying कि ये kinematics में उसके questions आ जाते हैं. Now, one important aspect of force is that forces can oppose each other. So that means the overall force will have a positive or a negative effect. So for example, there are positive effects of forces, like you can walk because of friction being there. The force of friction, when you start to move, the earth is pushing you forward because of that. So that's a force that helps you move. Similarly, if you're moving in a car and you want to stop, you apply brakes, and the brakes actually increase the friction that you have, and that friction allows the car to stop. Again, that's a positive effect. Negative effect of this thing could be that if you use a car for a long time or for long distances, there will be a wear and tear in obviously the everything that moves. So for example, the engine parts that are moving or the tires, all of those will experience some friction, and that friction will over time damage them. Similarly, when the cars are moving, so I'm talking in particular about cars, but it could be any engine that you have. So when the cars or engines are moving, the force that they're actually producing is never the force with which the car moves, because some of that force is used up, or it is countered by the friction that is generated. So for example, if I have a normal 4-cylinder car, then basically every cylinder or the piston that moves, it's going to be, its effect is going to be cancelled out to some extent by the friction that is in those cylinders. So if the car is actually producing enough power to move at 100 kilometer per hour, maybe it will actually move at a speed of 80 kilometer per hour, because those extra 20 wali jo force hai, that has been cancelled out by the friction in the car. Okay. So it can be a positive thing, it can be a negative thing. It all depends on what your perspective is. How do you cancel out this friction thing? You make sure that the contact is less. Okay, so you reduce the contact. So it's basically a contact force. Contact force simply means that whenever two things are in contact with each other, and if I try to push this here and push that here, obviously the surfaces are in contact, so that is going to create friction. Tires, they move on earth or the ground, so there is contact there. So, how do you stop or counter that contact force? First of all, if you have smooth surfaces, they have less uh, friction. So, you can polish stuff, you can make smooth surfaces, or you can even make it smoother by using some lubricant. So, you can apply some oil if you have two things that are rubbing together. Or sometimes instead of having uh, flat surfaces, we try to add spherical surfaces. So, for example, imagine moving a car without tires. So, that cart, when you try to move it, it will be very, very difficult to move. But imagine a sledge. So, when you're moving a sledge, you have a lot of friction there. So, while that is good when you're actually moving in snow or things like that, where you need high friction, but if you are moving on road where you want low friction, that sledge will be quite difficult to move. So we use spherical things like tires, or we can also use bearings. So for example, when you're making these drawers that you have of different like drawers and table and all that, they have bearings in them, small balls, steel balls that reduce the friction, so you can pull the drawer out and push it back in without having to apply a lot of force. Okay, so ball bearings are a good idea. Similarly, when things move in fluids, so then it's a different story when you try to reduce the friction. So we try to make things, for example, if a car is moving and you want it to move at a very, very high speed, we try to make it more aerodynamic. So aerodynamics simply means that we try to reduce the friction because of the air in the shape of the car. So high speed cars, high speed vehicles are all designed with aerodynamics in mind, that we need to reduce the friction. Why? Because air is going to create a lot of opposing force, and you don't want that your engine is running, you are spending the fuel or whatever form of energy you have, and it is countering the air resistance. So for example, it makes cars more energy efficient. Have you seen trucks? They are the ugliest things to ever move on this planet. So those trucks really have a big face, and that forehead that they have is just countering the increasing the air resistance that they have. So they use a lot of fuel. You could actually reduce the fuel if you had more aerodynamically supported trucks. But of course, people who design it and people who buy them, for some reason, they don't prefer that. Uh, they prefer shapes that are more angry looking. And those angry looking things obviously usually have a big face. So it happens with SUVs as well. You can design better SUVs, but people who buy SUVs or who prefer to move those cars usually prefer angry faces, which have apparently have big foreheads, so big grills and all that. So they try to look more intimidating, and basically are less energy efficient and less aerodynamic. Thank you. Thank you, Mine, for letting me know. I'm so okay. So अब forces, कुछ forces आपको पता होती हैं, जैसे we have heard about them. Force of gravity. Now there's an interesting thing. There are two things. One is the gravity, and one is gravitation. So the force of gravity can be called weight. Gravity is basically the weight that anything is having. So, for example, the pull of Earth on an object is basically the force of gravity that it has. But force of gravitation is the force that two objects have. Wherever they are in the universe, they can have this force of gravitation between them. Okay, so we have uh, weight. So F equals ma, right? So when things are attracted by Earth, the acceleration that they face, this acceleration is g. We usually give it that name. And the force that we have is called weight. So weight is basically mass times gravitational acceleration The G is basically the acceleration they have because of the pull of the earth. So this is force of gravity. But force of gravitation is always the force that is between two objects. For example, earth and the moon, they have this gravitational force, and both of them are applying that on each other. The formula for this is slightly different from this one. So they're slightly different. And the weight is usually what we experience in general, but this is what governs the laws of how things move in air and all that. So you don't really need to know this formula. Just remember that there's a force of gravity and there's a force of gravitation. We also have, whenever you stretch or compress stuff, there's this force of tension. So for example, if I have a pulley and there's a ring, there's a wire going around it and there's a pail of water or something, and somebody's pulling on it. So they're pulling on the string, right? So this string has a tension in it that keeps the string taut. So this is tension, and this tension is basically canceling out the weight that this thing has, so that the pail of water starts to come up. So that is the force of tension. You also have other forces, like one thing is called normal force or normal reaction force. Normal reaction is simply that if this is a surface and there's a book, let's say, so this is a book, then the weight of the book is pulling downwards. So according to Newton's law, there should be an upward force to cancel this out. So that is the normal reaction force. So the weight applies on the object and the normal reaction cancels that out. But what if I have a surface like this? So in this case, my weight is still downwards, but normal reaction is always perpendicular to the surface. So normal reaction is like this. So it might be difficult for normal reaction to cancel out the effect of weight completely. So if that is the case, then this thing will start to move down because the weight is pulling it down more than normal reaction can cancel out. So that's an important idea to remember. The normal reaction is always perpendicular to the surface. And if it is not providing enough force, weight will push things down the slope that you have here. So that is why when you put things on a slope and you increase the angle that at which the slope is, they start to come down. Okay. Then there are forces that we have seen which are different from gravity. For example, gravity is always a force that attracts stuff, but we have seen force on electrical charges. You can call it an electric force. So it can be a push or it can be a pull. It can be attractive or it can be a repulsive force. Or similarly, you can have a magnetic force. So magnets can be attracted or they can be repelled based on what pole they had. So that's also a magnetic force, and that also is a natural force that you have. Okay. So अब यहाँ पर एक idea when things move, the idea is about the distance that they travel. So whenever you are moving or you're driving a car or something, the braking distance is usually the idea that when you look, so for example, there's somebody moving and they decide to apply a brake. So there's going to be some distance, some time spent while they weigh their options. They decide how much they want to apply the force on the brakes or how fast they want this brake to be. And the car is still moving, so there's going to be some thinking distance. The distance that the car travels while the driver thinks about applying the brakes. And then obviously there's the actual braking distance, the distance that is traveled while the brakes are being applied on the machine. So when the driver is thinking about it, the car doesn't know that it has to brake. So it does travel a certain time, and you might think that, oh, it doesn't really matter, but when you're in practical situation and the speeds are high, it does matter because you're traveling at speeds that are really high. So even if you take, let's suppose, half a second to do that, you will be moving at quite a large distance. So can you calculate this? Go on. If somebody takes half second to decide if they want to apply a brake at a speed of 60 kilometers per hour, how many meters would their car travel while they decide? Go on, calculate it. Half second, Maheen. It's not half an hour. Who thinks for half an hour before they decide to apply a brake? Do they have driving schools in Sri Lanka? 60 over half. Um, Again, 60 kilometers per hour is the unit, and that is half a second. So you need to convert the units, you need them to be consistent. 8.3 meters. How did you figure that out, Zainab?
Sir, can I speak?
I'm sorry?
Can I speak?
Yeah, sure, of course.
So multiply 60 by 1,000 over 3,600.
And why are you doing that?
To convert it into
But why
meters per
1,000
second.
and 3,600? Why those particular numbers?
There's 1,000 meters in 1 kilometer, 3,600 seconds in 1 hour.
Very good, very good. Then?
And then you
What will you
multiply
get?
that value by 1 over 2.
So that is your speed, right?
Yeah,
in meters per second.
Speed.
Yeah, so you
Then
converted
multiply by time.
60 times 1,000, so that becomes 1,000 meters. Why? Because 1 kilometer is simply 1,000 meter, and then 1 hour is 3,600 seconds. So you did that. What did you get?
50 over 3.
50 over 3. Okay, so 50 over 3 meters per second is the speed. And then this person, obviously they're spending half a second, so it's going to be 50 over 3 times half, because speed is distance over time, and we assume that they're moving at constant velocity. So speed times multiplied by time is going to be the distance. So that is 25 over 3, or 8 whole 1 by 3, as Zainab said. So that is the distance that they've traveled. That is almost 25 feet that they've traveled while they were just thinking. Okay. And obviously, then they apply the brakes, and then it comes to test. When they're applying the brakes, that's acceleration. And whenever they are applying the brakes, usually we want the thing to come to a complete stop or slow down. And usually, आपके exam में जो questions आते हैं, they want you to slow down to 0. So if they say that we want it to stop, then that simply means the final velocity is 0. So if you have this formula, v equals u plus at, you will put the final, this is your final velocity, this is your initial velocity, this is your time acceleration, and that's your time taken. So let's suppose they say, okay, so this car, we want it to stop to complete 0, and the acceleration that the car has is 5 meter per second squared. How much time does it take it to stop? So obviously you'll say, okay, so the final velocity I want is 0. It's currently moving at a velocity of 8 whole 1 by 3 meters per second. So no, not that. 25 over 3 है ना? नहीं, 50 over 3 50 over 3 meters per second. Acceleration is 5, which is actually minus 5, and the time is unknown. So we'll calculate this, and we will get that the time taken is going to be 3.3 seconds, or 3.33 seconds. So that means the total distance that they're going to travel. सबसे पहले तो उन्हें half second लगेगा सोचने में, और फिर 3.33 second लगेंगे actual brake apply करने में. So overall, this person is going to spend 3.53 seconds just braking and coming to 0. And obviously, you can calculate. Again, in O levels you can't, but in A levels you can calculate how long it will take them to actually come to a stop. You can get a rough idea by reducing the speed by 5 every second. तो आपको पता चल जाएगा कि अच्छा हर सेकंड में 5 फॉल करी तो कितना डिस्टेंस ट्रैवल करेगी. So usually आप thinking distance उसे निकाल लेते हो और braking distance निकाल. तो overall stopping distance is going to be this total distance that they traveled while they were trying to stop. So stopping distance involves or includes the thinking distance and the braking distance. All right.